All right, good morning, class. Good afternoon. All right, so today is another session of Mathematics Foundation Unilag. All right, so today we'll be treating indices and logarithms. Indices and logarithms. So when we say indices, I believe this is a topic we are familiar with in our O-level topics and all. So when we say indices and logarithms, what do we mean? So indices simply means the exponent of a number or the power of a number. So when we say indices, we are dealing with powers, we are dealing with exponents. While logarithms is simply like the reverse engineering of indices. So now I'll explain in this way. So when we say indices, the indices of 2 indices 3 or 2 raised to the power of 3 or 2 with an exponent of 3 is 8. So now this here is written in indices form. How? Because there is a power. So indices is simply representing a number with a particular power. So I have 8, and I want to represent it in indices form. I'll say 8 is equal to 2 raised to the power of 3. So now 2 raised to the power of 3 is me writing indices 8 in its indices form or in its index form or in an exponential form. So that is what indices is. Now, indices says a number raised to the power of this will give me this number. So indices is saying 2 raised to the power of 3 will give me 8. What logarithm does is, logarithm is simply saying, what will I raise to the power of 8? What will I raise to the power of 2 to give me 8? So like indices is the reverse of logarithm. So when I say log 8 to base 2, what I simply means is what this means is what number do I need to raise to the power of 2 to get 8? So now when I write 2 raised to the power of 3 equals x, this means when I raise 3 to the power of 2, all right, what do I get? Why this when I say log 8 to base 2 is equals x, it means what will I raise to the power of 2 to get 8? So logarithm is simply reversing index. So now in logarithms, this is the result. This is the index or exponent or power. You can call it power, you can call it exponent, and this is the base. So now you can use the same thing in when you want to convert from logarithm to indices form. So if I want to convert this, since this is the index and this is the base, I'll say 2 raised to the power of x equals 8. Index, base, result. Now I've rewritten this from logarithm form to indices form or to index form. So that is the relationship between indices and logarithms. So you'll find out that when you are treating this topic, you always treat them side by side because they correlate. So logarithm is simply the reverse engineering of indices. When you have a logarithm question and you want to reverse to indices, just have this at the back of your mind. This here is the result. The value you have in front of your log is the index or power or exponential. Y2 here is the base. So if you want to write it in index form, you can say 2 raised to the power of the index is equal to the value. So now let's say we have log 100 to the 10 is equals y. If I want to rewrite this in indices form, I'll say 10 raised to the power of y is equals 100. How do I come up with that? This is index, this is results. This should be 100. Sorry. So that is basically it. I believe reading. Let's say I have all right. So let me say I have 2 raised to the power of x equals y. I have 2 raised to the power of x equals y. And I want to write this in logarithm form. I'm going to say log y because this is the result from here. Log y to base 2 is equals x. So now if you compare, if I want to rewrite it back using the same format, I'll have 2 raised to the power of x equals y. So that's basically how to convert from indices to logarithms. With written questions. So logarithms is in our just like the number basis we use in real life mathematics, in arithmetic that we use in real life, they're always in base 10. So same thing with logarithm. The logarithm we use in normal mathematical functions is in base 10. So if it is not specified, just like the logarithm on your calculator. So if you have log 100, this means this is the same as log 100 to base 10. So if you don't have a base, it means the logarithm is in base 10. All right. So if you see questions where there is no base and you're wondering where the base went to, it's simply in base 10. So if you're not given a base, you mean you should calculate. So if you do log 100 on your calculator, you should get 2. Why? Because this log 100 is same thing as log 100 to base 10. And if you are going to do that, you have what this is saying is what number do I need to raise to the power of 10 to get 100? And that is 2. All right, so that is it on logarithms. Before that, I would like to write down laws of indices and laws of logarithms so that when we are calculating or when we are solving our working examples, we would have something to refer back to. All right. So for indices, I'll write the indices law here, I'll write logarithm law here. So, and I won't touch this board, so it will be on the board till the end of the class. And then any examples we'll be working on that on this end. So the first law says a raised to the power of m multiplied by a raised to the power of n is equal to am plus n. Why? Because when you have the bases, they are the same, all right? Then you are multiplying, then you just add the powers together. That is the first laws of indices. Am divided by an will be a raised to the power of m minus n. Same thing, the bases are the same, and you are dividing, you subtract the parts. So you have a raised to the power of 1 over n. This becomes n root a. So when you have something like this, a raised to the power of 1 over n, the power is in fraction, 1 over n. You have n. So if you also have a raised to the power of 0 is equal to 1, another is a raised to the power of m, a raised to the power of m, all raised to the power of n is equal to n. So if you have something like this, you just multiply the powers together. All right. There is also a raised to the power of m divided by n. This will be n root a m. So now these are the laws of indices that you need to have at the back of your mind. Multiplication law, the division law, the fraction law, the zero index law, the exponential law, and then the fraction law. So this is m divided by n is equal to root n a raised to the power of m. So these are the rules of indices. So when you have questions like this, you just need to fall back to these rules, and then you can be able to simplify and solve. So now for logarithm is simply the inverse of indices. So I'm going to show you that here. All right, I'm going to show you that here. So for logarithms, when you have log AB, all right, you have log AB, it's the same as log A plus B. Sorry. I'm looking for how to write this, but then I think we have to break into this board. All right. So rather, I want to say log AB is the same as log A plus log B. I hope you guys are going to write this down because I will have to clean this. So I'll give you a minute to write all of this down. So when we are done, we can clean it. And if we need to go back, we'll go back to it. So let me say, if this is now, in this case, I didn't write any base to it. So if I want to write base to it, I can write x, x, x. Or in any case, if there's no base there, it's same thing. It simply means log AB when you're multiplying the product of two logs. When you want to break it down, you can have log A plus log B. So here where we had addition, it's changing to multiplication, same thing here. So you can also simplify this from log A to base x plus log B to base x to become log AB to base x. Same thing with subtraction. If you have log x, A divided by B, all right, this will become log A to base x minus log B to base x. Also, if you have 2 log x to base A, this is the same as log A raised to the power of 2 to base x. So if I want to do this, I can rewrite this with, instead of writing 2, I can change this with m, and this becomes m. So what does this mean? When you have a number in front of a logarithm value, it can become a power. And it doesn't only work in one way. It can actually work. Actually, I was supposed to write this from here down here. So most times when you are solving logarithm questions, you will most likely see the questions like this. like this, like this. But that doesn't mean you can't meet it in this form. So regardless, any form you meet it and you need to simplify, you just need to convert. So if you are dealing with addition and you need to simplify it, you can convert it using the multiplication law. You have log a b to the base x, or you're working with subtraction. In any case, this is equal to this, and this can also be equal to this. All right, they work in both ways. So log a raised to the power of m to the base x is the same as m log a to base x. So let's say we have something like log 10 raised to the power of 2 to base 10. If I want to simplify this, I can simply say log 10 to base 10. 2 log 10 to base 10, because this power here now becomes a coefficient, or we use it to multiply this logarithm expression. So now there's also another rule that says log m to base m is equals to 1. Log m to base m is equal to 1. All right, so these are the rules of logarithms, and these are the rules of indices. Let me see if I'm missing anyone out. You can write this down real quick. So these are the rules you need to put at the back of your mind. They are not complicated. You just need to have this at the back of your mind. All of these letters, once you have numbers, you find out that it is very easy to work with. So we'll be taking examples, and you guys will see the applications of all of these in working examples. All right, so okay. All right, so let's take working examples. I believe you guys have written this down. So working example from foundation, Unilag foundation past question. Unilag foundation past question, year 2009, question 1. All right, so this is the Unilag foundation past question. If you have it, you can just join us. Year 2009 mathematics question 1. Here is the past question here. You can get it for yourself to practice. All right. So the question says evaluate. All right, I'll clean this board now. Okay, the question is there on the screen. It's 1 raised to the power of 3 over 4. It says simplify or evaluate. It's 1 raised to the power of 2 raised to the power of 3 over 4 minus 27 raised to the power of 1 over 3, all divided by 3 times 2 raised to the power of 3. Okay, so we have it's 1 raised to the power of 3 over 4 minus 27 raised to the power of 1 over 3, all divided by 3 times 2 raised to the power of 3. So we're going to solve this one after the other. So this is indices. This is an indices question. How do I know it's an indices question? Because we can see exponents in the question. So, all right, taking the first from this first one, I want to simplify it's 1 raised to the power of 3 over 4. Now, if you remember, there was a rule that says a raised to the power of m over n is equal to root n m a raised to the power of m. So that's what we have here. So I'm going to do the same thing here. All right. So I have 81 raised to the power of 3 over 4. This will become 4th root of 81, all raised to the power of 3. 4th root of 81, all raised to the power of 3. So what's the 4th root of 81? 4th root of 81 simply means what is the number that I need to multiply 4 times to get 81? The number I need to multiply by itself 4 times get 81. That is 3. 3 times 3, 9. 3, 9 times 3, 27. 27 times 3, 81. So this is fourth root of 81 is 3 raised to the power of 3. So 3 raised to the power of 3 is 27. That's 3 times 3 times 3. So now evaluated the first part is 27. So now, yeah, I have to do 27 raised to the power of 1 over 3. Remember, there is a rule that says a raised to the power of 1 over n is the same as nth root of a. What am I going to do here? So this means 27 raised to the power of 1 over 3 will become 27 raised to the power of 1 over 3 is 4th root of 27 or cube root of 27. All right. What is the cube root of 27? The number I need to multiply 3 times to get 27, which is 3. So which means 3 times 3 times 3 is 27. So the third root of this is of 27 is 3. So I've evaluated this to be 3, evaluated this to be 27. Now for this, I have 3 times 2 raised to the power of 3. What is 2 raised to the power of 3? 2 raised to the power of 3 is 2 times 2 times 2. 2 raised to the power of 3, 2 times 2 times 2. So this becomes 8. So I'm going to do all of this right here. So the first one is what I calculated here as 27. So I'm going to say 27 minus 27 raised to the power of 3. I've calculated it to be 3, all right, minus 3, all divided by 3 times, that's 3 multiplied by, what is 2 raised to the power of 3? 2 raised to the power of 3 is 8, all right, 2 raised to the power of 3, 8. So I have this 27 minus 3 divided by 3 times 8. Can you see all of what is here is what we simplified to become this? So now you can just do our basic arithmetic. 27 minus 3, 24, divided by 3 times 8, 24. So 24 divided by 24 is 1. So all of these, when you evaluate this, it's 1 raised to the power of 3 over 4 minus 27 raised to the power of 1 over 3, all divided by 3 times 2 raised to the power of 3 will give you 24 divided by 24, which is 1. And that is option B. So you can see, following the rules of indices that I've given you in the first part of the class, you see how we were able to break this down to get this. All right. We'll take another question if you have any question on this. Okay, let me just go over it quickly. It's 1 raised to the power of 3 over 4. That's what I evaluated here by using the rule of indices that says a raised to the power of m over n is equal to nth root of a all raised to the power of m. So what you need to do is just relate the question with the rule of indices, the one that looks familiar, and you apply that rule. When a question is similar to a rule, then you apply that rule on that question. Basically, that's it. The same thing for 12, 27 raised to the power of 1 over 3, all right, which after evaluation gave me 3, and then 2 raised to the power of 3, which is 8, and then we simplify. I hope that's clear. All right, so let's take another question. Still on year 2009, question 2. This question says, find the value of x for which 2, all into brackets, 3 raised to the power of 2x minus 1 is equal to 162. So find the value of x. Here I must find the value of x. This is also an indices question. But here I can find out that there is a variable in the exponent, or there is a variable in the power. So first thing first, I want to simplify this question. Simplify this question. Why do I need to simplify this question? Because here 2 is a common factor in both on my left-hand side and the right-hand side. So what do? I can divide 2 by 2 to simplify this expression, or to simplify this equation rather. So if I divide 2 by 2, if I divide this left-hand side by 2, and I divide the right-hand side by 2, this will take out this. Then I'll have 3 raised to the power of 2x minus 1 is equal to this in 2 ways. I can decide to apply the indices rule on this to solve and then evaluate, but then I'll do it in the very simpler way, which is I'm going to make this to become, I'm going to write this as an exponent of 3, or I'm going to write it as an indices of 3. This 81, I'm going to write it as an indices of 3. And because both the left-hand side and the right-hand side have the same basis, then their powers will be the same. So that's the easiest way. So if I'm writing this as an indices of 3, what does it mean? I want to represent 81 as an indices of 3. So what do I get? That will be 3 raised to the power of 4. How do I know it's 3 raised to the power of 4? Because if I multiply 3 times, if I multiply 3 4 times, I'll get 81. All right. So now this becomes 3 raised to the power of 2x minus 1 is equal to. So instead of writing 81, I'm going to write 3 raised to the power of 4. 3 raised to the power of 4. So yeah, like I said if the bases are the same, it means the power or the exponents will be the same. So this means 2x minus 1 will be equal to 4. Or you can say if the bases are equal, then the power will be equal. So I have 2x minus 1 is equal to 4. So yeah, I collect items, constants to one side, and then the variables on one side. This is 4 plus 1, which is 5. If I divide through by 2, I'm going to have x is equal to 5 over 2. Pretty simple. You just need to simplify. Yeah, we are not even using any indices law here. We just need to simplify and get our answer. What you just need to know how to represent. These are different formats which you can be tested on indices in your exams. So I believe if we've done all of this, you should be able to tackle any questions on indices you meet in your exams at the end of this class. All right. So that will be it on indices. So we'll be giving you examples at the end of the class. I'll give you guys exercise at the end of the class. But for now, let's move to an example on logarithm. So question 5, 2009. Question 5, 2009. It says simplify log 48 to base 2. Simplify log 48 to base 2 minus 3 log 4 to base 2. Log 48 to base 2 minus 3 log 4 to base 2. So now, if you remember the logarithm law we were talking about, the logarithm law I gave you in the first part of this class, there was a subtraction law that says when you have division, you turn this to multiplication. Now, in this question, we are going to use two logarithm laws. Now, you see this, we have 3 log 2 raised to the power of 4. So here, this looks like m log a x is the same as log a raised to the power of m to base x. So now you see this format, this is very similar to this that we have here. So what do? We rewrite this as this. So this will become 3 log 4 to base 2 will now become log 4 raised to the power of 3 to base 2. Because this is similar to this, we can use the indices law, the logarithm law rather, to rewrite this as this log 4 raised to the power of 3 to base 2. So now, yeah, I can bring this down back. So I have log 48 to base 2 minus log 4 raised to the power of 3 is 64. That's 4 times 4 times 4, 64 to base 2. So here now we can apply the logarithm subtraction rule. The logarithm subtraction rule where you have log 48, when the bases of the log are the same, you can divide when you have subtraction. Or if you have addition, you multiply. So this will become log 48 divided by 64 to base 2. Log 48 divided by 64 to base 2. So what I'm doing here is I'm converting this to a single unit. So if you have this, you can also rewrite it as this. All right, so log 48 to base 2, this becomes log, I think 12 is a common factor. Okay, we can divide this to get what we have. 6 divided by 8, and this will become 2 is still common, that's 3 over 4. So this becomes log 3 over 4 to base 2. All right, so 16 is the common factor. So if you divide 48 by 16, you have 3. You divide 64 by 16, you have 4. So 3 over 4, I'm simplifying what is in this fraction, 48 divided by 64. to become 3 over 4. So you have log 3 over 4 to base 2. So the question says simplify. So now there's difference between simplify and evaluate. Evaluate means you have to look for a result. Evaluate means you have to look for a particular result. Say the answer is 4, or the answer is 17, or 3 over 2. But then simplify simply means you have to break it down to the simplest form. That is simplify. So simplifying this that we were given in the question now becomes log 3 over 4 to base 2. Now you can see it is written, all of this here is now written as a single unit. So all I need to do is apply the logarithm rules in the question. And then I broke down this one, which is the 3m log a raised to the power of x to become log a raised to the power of m is x. And then from there, after getting the answer, I applied the subtraction, logarithm subtraction law to get log 3 over 4 to base 2. All right, so let's take one more question and then I'll give you guys an exercise to work on. So year 2023, question 1. Question 2023, year 2023, question 1 says find x if log x to base 2 minus log it's 1 to base 3 is equal to 1. Find the value of x if log x to base 2 minus log it's 1 to base 3 is equal to 1. So here now I have subtraction. But now if you look very well, if you look closely at the question, you find out that the bases are not the same. Because the bases are not the same, we can't apply the subtraction rule to this question. We can only apply the subtraction rule when the bases are the same. Now you can see in this question, we have base 2 and here we have base 3. So it means we can't apply the subtraction rule. So here I'm going to simplify all of this. I can simplify this to become log x to base 2. And how do I simplify this? I'll first convert it to the indices form, then I'll look for the value of x. So how do I convert this to the indices form? So I can write this as log it's 1 to base x. All right. Just like I said, if you want to convert to indices form, log it's 1 to base, sorry, log it's 1 to base 3 is equal to x. So now, like I said, this is the power, this is the base, and this is the result. So this will become 3 raised to the power of x equals to 81. Power, base, result. Result, the power, base. 3 raised to the power of x is equal to 81. I'm looking for x. All right. So now x is what I need to do to get x is write 81 as an index of 3. Writing 81 as an index of 3. And what is that? That is 3 raised to the power of 4. So which means x is equal to 4. So now I've gotten x at 4. This means log 81 to base 3 is equal to 4. So now instead of writing log 81 to base 3, since I know log 81 to base 3 is 4, I can replace it with 4 in this equation here. So I have log x to base 2 minus 4 is equal to 1. So here I can collect like terms and say log x to base 2 is equal to 1 plus 4. Log x to base 2 is equal to 5. So here I can convert this to indices once again, to get the value of x. How do I convert to indices? Power, base, results. So that will become 2 raised to the power of 5 is equal to x. And what is 2 raised to the power of 5? 2 raised to the power of 5 is 2 multiplied by 5 in 2 multiplied by itself in 5 places. That's x is equal to 32. 2 times 5 times 2 times 2 times 2 times 2 times 2. All right, you get 32. So 2 raised to the power of 5, 32. So the value of x here in this equation is 32, which is option D in the question. All right, so you just need to have the you come across any questions, you can be able to solve them. All right, let's take a quick exercise. Question 7, year 2023, question 7. The foundation, Unilag foundation. You can see it on your screen. Year 2023, question 7. You need to solve, or you need to evaluate the value of log 3 root 3. And in the question, it says log 3 is equal to 0.4771. So evaluate the value of log 3 root 3. So one hint I will give you for this question is you have to evaluate, which means you are looking for a single value. So to get this, now you have to reverse what we have, just like the laws I gave you in the beginning of the at the beginning of the class. When you have multiplication, you can break it down to become addition. So if you can break this down, you can separate this log 3 and then log root 3. And then you can, after separating log root 3 and log 3, then you can rewrite log root 3 in the form of log 3. That's expressing the log root 3 as log 3. So when you have all your expression as log 3s, the only logarithms you have in your expression log 3, and I'll replace them with this value 0.4771. Pretty simple. That's how you go about it. So you should have a single value. All right, so when you're done, just send your answer in the chat box. So you have like a minute to do all of that. So if you're done, send your answer in the chat box. I'm still waiting for you guys. Solutions. What? Mm. All right, so I'm waiting for your answers. Karim, can you unmute yourself? If you're with us, unmute yourself and tell us what you have. Maybe I should start calling you guys one by one. Karim, if you're here with us, unmute yourself. Can you unmute yourself and tell us where you are, the stage you are, um what challenge you have on this question? Unmute yourself. You are on this class, or you all are afraid to speak? Oluwanifesi, I see what. Okay, yeah, you can unmute yourself. All right, so let's do this together. If everybody is too, okay, Oluwanifesi, I see your got 0.7157